Hey folks, this time with a little bit of another video, which is a progression report where I would like to show some of my work I did the last couple of days. So in the first part of this video, I'm going over something I changed in Visual Studio. That is, I completely removed Visual Assist. I couldn't take it anymore. It just don't work for me. And the second thing is I would like to test a bit more on the syntax highlighting, because I got so used to the Visual Assist syntax highlighting that it's very alien to me to use something different. So I would like to change that frequently, and that's basically the first part of this video I was going through. And the second part is basically about variadic args or variable arguments, so a function which is a lot used in C, and I never really used it except this time I integrated it into my logging system and it works great. So this is the second part. I'm going a bit into it. Yeah, and the third part of the video, actually I describe a bit how I parallelized or make a async thread in the rendering thread in order to offload certain tasks like creating graphics objects, releasing graphics objects, and compiling shaders on that other thread asynchronously, so that the rendering is not disturbed by any compilation whatsoever. And it turned out to be a very great tool, and it was successful, and I like it a lot. So that's the third part of this video. Yeah, this video is actually not about any deep dive, so please don't expect that. That's really just a progression report. And yeah, I kind of freely spoke there and tried to explain what I did. And yeah, there's a lot of stuttering in there. I'm sorry for that, and a lot of cuts. So yeah, I tried to improve that. But yeah, for now, I think, yeah, it's just a report, and I hope you like it. So yeah, enjoy. So the second thing I really added to the logging system is when I'm working with variable arguments. So I added some functions here, and to make this a bit more efficient, everything of those of every log I want to do is put in a temporary buffer. And vs and printf, we can actually access those variable args with the VA list types and the VA start, VA end, and then we can just print variable arguments into that buffer, and then we can pass that complete buffer to the logger. So here's an example. I typed it like that. So I just wanted to use a bit more C++ style. So with just concatenating with the plus operator. Yeah, that's very inefficient, because there are a lot of memory allocations done if you do it like that. Because every time it uses a string, it allocates memory for that. And yeah, I had big issues with that in terms of performance. So I just removed all of them. Not all, as you can see, but this is not so. This is not so big of a deal, because this is guarded by this if statement here. And yeah, this is just called when this actually fails and that writing is not so bad. And here with the OpenGL error checking function, you can actually see how it's used. So we can specify the size of the buffer it should use. You can just print all the stuff in it. So we can just build our files or the code with this kind of error handling. So yeah, this one is still a bit, I think, inefficient, because we could have a macro function that actually calls this one, maybe also with variable args. So we could just use this name, put it into the macro, and then with variable args behind it, just call this function here. That would be a nice thing. Maybe I'm looking into that a later time. So this could be reduced to one line, those two, and you don't have to write the function name again. That would be nicer. Yeah, and the third and maybe biggest change was in the rendering backends, because yeah, the last few live streams I made the graphics demo. I would like to make that graphics demo, and I realized when switching the scenes, like in the demo, there are scenes I will show it in a bit. And if you play it, then I'm doing it like that I'm loading a scene, and then when the next scene comes in, it should hot load it. So everything needs to be loaded or read from file, and then everything needs to be compiled and created and so on. And that actually caused the program to stutter, to being stuck at those moments. So when the shaders compile, the program it stops for a moment, and that's very ugly. So what I did there is to implement in the back ends of the rendering pipeline, I made another thread, and I'm shoveling the creational command that has to do with creation and release to that thread, so that the main rendering thread is kept clean of those tasks, and so it's just rendering. I'll show it in a bit, but before I'm doing that, just quickly explain it. And that is I created this data structure where I am able to access a particular item. For example, we have those MSL data types here, which is which contains in the backend, which contains the motor shading language data, and that is the shader and everything that is required by that shader to render. We have this data structure which allows concurrent access to those items. Data structure is holding a linear vector of those items, and I can access it concurrently with reader logs. This is when we just need to read it and see, is this item there? Is this OID there? The OID is the object ID that is assigned to that object by the backend. So if we have an OpenGL backend, that it's getting an OID by that backend, and if we have a D3D backend, then this particular object is getting an OID of that backend. So we have to check that if that item is there, and if it's there, we can directly access it. And if it's not there, we need to create it, and then we have the writer log. So we write it, and in this function, actually, it's checked again. So we first check it, and if it's there, we can use it. If it's not there, we create it, and then naturally, in the third step, we access it. So this at the moment is just assuring that this items array is not resized during its usage. Yeah, that's the first part. So I needed to do that for all the types. There are actually quite a few. It's for the MSLs and for the frame buffers and for the shaders and the render objects and the state objects and the array data. There are some data types I needed to change. That took a bit, and because every time, let's see if I find it. Here, for example, we have the image data that is stored in this data type I just explained, and then we can place all images into this data struct, and then we can access it like so. We say images.access, and then we use that ID. This is a unique ID for a specific object, so in this case for a specific image, and if that ID is valid, we know the image is there, and if it's not, it will be created in this data structure here. And so what I did there is before that we had the square bracket operator to access it, and that was not thread safe. So that is usually also used for direct access without any safety in mind. So that was just a direct access. So we have now this function where we can directly access it through this access and the mechanisms of locking that particular data structure. Now, with the asynchronous processing of the commands, or the async processing, because the rendering is already async. So Yeah, here in this window you just saw how this model was built up. So a little post edit here. In this part I just wanted to show how long it actually takes to compile the shaders and how the model that is loaded is building up while it is rendered. So first I'm using the release mode, which was kind of okay. It quickly compiled and it was there quickly. But when using the debug mode, it just takes its time and it takes very long to compile. Yeah, as you can see, if you have a lot of shaders, that builds up quite a bit. And it takes its time, so we can absolutely not afford to compile it along with all the rendering commands. So this one was done. I would like to change to debug mode. So now the application starts, and yeah, as you can see, here's another problem with the memory allocations and the geometry creation. But as you can see now, the shader compilation takes quite a bit. This is because the generating the shaders from the motor shading language to the particular API shader takes its time. It's too resource expensive at the moment. I'm working on that too. As you saw, it was it just built up during its rendering. And to show this even more properly, let's move the camera. So while this builds, when it starts compiling, now we can move the camera, and as you can see, yeah, it's not, there's actually no stuttering in there. You can go, and it's absolutely smooth. I like that. So I was just increasing the velocity of the camera a bit. Yeah, once again, so we move the camera here, and as you can see, that's going quite well, I think. So while this thing builds up, it's not stuttering at all. And we can actually now go a bit further. So I did this for the D3D11 backend and also for the GL4 backend. Those are the two I have at the moment. And yeah, if I press F3, we open another window, and then we see the same behavior for the GL. So let's just do that. Open the window, and then we can move the camera, and as you can see, it's nearly flawless. So I can't even see well, there are very, very tiny stutters, but I think that's absolutely you know, like bearable. So so we can just use that for you know, the style of hot loading I wanted. So let's kill that window and open it again, and then we can just see it again when we move the camera, and the scene slowly builds up by compiling all those shaders. And when the shaders are ready and that background object is created, then the rendering system will render it. So let's do that again. There are tiny stutters, I think, but I think we can just, you know, ignore that, and I think it will become better in the future. Yeah, that's kind of a complex object, because, you know, I think there are many shaders involved. So let's try that again. So we clear the window and have to select that, open a new window, and you can see here how the shaders are actually compiling. I just forgot to press the record button. Anyway, so now let's go back to the demo I was working on before I had to introduce the new features. Here the important window is this window. We see here all the scenes that are currently in, and which will play when the time goes on. So at this time we have scene 0, which is green. That means it's loaded. And if we progress in time, then this one will become yellow for indicating that it's loading, and it becomes orange if the scene is loaded fully, and green when it's executed. The reason why I did all my changes, or the changes to the backends of the rendering, was that when we have this transition, when two scenes are played at the same time, and the next scene will will be loaded into memory. Then I got a lot of stuttering, or the demo just stopped for a moment, or not even for a moment, but really a second or so, until all the shaders were compiled. That was the big issue. It takes the most of time in the backend. Now we are in the threaded backends. This has reduced a lot, and I will show you in a moment. So we play the demo. Let's just change those a bit. So here the demo plays. This is the debug window where I can just move the free camera. I can attach to those cameras and things like that. But now here's the GL window. So this is rendered with OpenGL, but when I press F3, it opens the production window, and then we can see how it looks when the demo's done. So when the demo plays, the second scene actually, now you see that we are already in the time range of that second scene. So it has its time range, and before that time range, it has some certain period of time that hopefully is enough to fully load the scene. Like for example, 2 seconds or 3 seconds. So when we are in that time range, 3 seconds before the scene is actually required, it starts loading the scene. In that time span there, before my change to the backend, to the async threads that compile the shaders, the demo stopped for half a second, and then it goes on, and that is nearly gone at the moment. And let's go a bit back in the timeline, and we see the scene 1 is not loaded at the moment. So we press play, we just wait. Now there was a tiny stutter, I think. There's a tiny stutter when the demo just loaded, but you can see here it's a very simple crossfade. So scene 1 doesn't show because it wasn't loaded. So scene 0 is black now, so it's not loaded. So when I go back here, it takes a bit for those objects to appear. This is because scene 0 is not loaded, so all objects are dumped. And if you go straight into the time range of that scene, it needs to load, of course. So it needs to allocate all the memory. It needs to compile all the shaders and create every rendering object and everything it requires to render this worm here. So this is because the objects are not there at the moment I'm pressing in. But the point here is that is that this severe stuttering or even the freeze is gone, and that's awesome. So here that's a bug actually. I have to fix that. But as you can see here, the second scene comes in with the debug cube, and it just fades in, and there's I don't know if there's even any stutter. So there are a few issues there, but that's not a bigger problem. I can fix that. There may be a tiny, now we are here with a exception, but that's not a problem. There are things I have to fix there because it's very new, and I just tried it, and I think it works great. So I will go on there, and that was the progression report, and I hope you liked it, and maybe we see us in the live stream. So bye.